because I know you're here really for the content. But if there's any questions at all during the session is going on, feel free to ask, because I'm here to help you to solve your doubt. And I know you have a quiz coming up, so I'll try my best to prep you for that. Okay, but unfortunately, I won't be able to go through any assignment questions for this year, because those are against the academic integrity of the university. But I will teach you the concept of the course itself to make sure that you will be able to handle any kind of questions at all. And I'll also be able to tackle similar questions that have come out in the past. Okay, so to make sure that we get enough practice to prep you to build a solid foundations for the entire course, because the first chapter, it really is the tool and the foundation for the remaining of the course. Like, to be honest with you, there won't be any questions that will come out during the midterm for the first chapter, because it's really too simple to ask any questions in the first chapter, but they will sort of be the foundation, or they will sort of be the tool for any remaining questions that will come out in the midterm. Okay, so it's really important to make sure that you have it at your fingertips, and you should be familiar with those concepts such that you don't even have to think, right? You should be familiar with those concepts such that when you see the problems, you know exactly what you have to do, and you won't have to spend too much time doing it. All right, so today's sessions, unfortunately, is going to be a bit more boring, because there won't be too much problem solving. There will be a bit, I'll try my best, but most of it is really just going through the basics and grinding it again to make sure everyone is up to the same speed, because some of you might be ahead due to your high school curriculum or whatever background that you're from. But so the first chapter is really to make sure that everyone is up to speed and at the same page before we go further in. So you want to make sure that you are not left behind. And if you're ahead, that's good for you, but I would remind you to not underestimate the course as well, because it picks up really soon. Okay, until now, do you have any questions? We good? Right, great, thank you. So let me now share my screen with all of you. Can you all see the screen that I'm sharing right now? Okay, good, thanks. Right, cool. So, so before we dive into the chapter, I just want to show you a little bit about what we are supposed to go through during the first week, okay? So the first week, it's really just to have your trigonometry background set up, to make sure that it's really up to speed, to make sure that you have everything that you need. And the second thing is really to get your vector operations foundation solid, okay? Because vector operations, it comes out all the time in your exam. And after that, we will go into a little bit of free body diagrams. And then if we have time, I might go ahead and try to go into moment, which as far as I know, it's not covered yet in your lecture, because this is meant to be a bi-weekly review session. So every time I'll try to cover 2 weeks worth of content. And as far as I know, you all are up to 3D Cartesian vector, if I'm not wrong. Please correct me if I'm wrong, okay? But so if we have time, I'll try to go into moment a little bit, depending on our progress, but I'll make sure to cover up to whatever you're supposed to do for the upcoming quiz. All right, are we cool? Questions? All right, great. So let's dive right into the content. So the first part, it's really simple. It's really just a bunch of, I would say, definitions that you have to understand the difference of it, because sometimes a different interpretation of the word can give you a very different outcome in terms of interpretation of the problems or even the final solution itself. Okay, so I'm just gonna quickly go through it to make sure that everyone has the basic understanding of whatever we are talking about. It's really just the language of it, right? So a particle, when we talk about the particle, which means that the particle have mass. Okay, we care about the mass itself, but then the size can be neglected. So which means that if I give you a dot and I say that this dot is 100 kilogram, then it is 100 kilogram. You just take it as it is. There's nothing for you to worry about, because the mass will be given. And if you give you the exact same dot, I'd say it's 5 grams, then it is 5 grams. There's really nothing for you to care about. It's just a dot that exerts a force on your entire structure. Okay, so that's a particle. But the difference is that when we come to rigid body, we have a structures, okay? So we have a structure means that there is a geometry, there's the size, there's the geometry that we have to care about, okay? There's the shape of it that we have to think about it when we go further into the course, and then the shape does not change when a force is applied. And this applies to 99% of CIV100. Okay, so 99% of the time, you are dealing with rigid body where when force is applied, the shape of the thing does not change, and except spring, right? Because we know spring is deformable, and we will go through the equation for spring later on. But other than that, everything that you see in CIV100 is basically a rigid body. It's basically a solid, which means that you don't have to worry about it being deformed. The shape will be retained. The geometry of the structure will be retained throughout, all right? And do we have any questions until now? Let me know, okay, if you have questions. So the third one, it's concentrated or point force, which really means that it's basically the same idea as your particle, right? What it really means is that the force is only being applied at one point on the body. So like when I give you an arrow and acting on a point on the body, I say the arrow is 100 Newton. Then 100 Newton it is. There's really nothing for you to worry about, okay? It's really just a number that's being given, and then you have to assume that it's acting on a single point at the body. That is the important part of it, right? And again, that if there's a concentrated force, then another way for you to apply force is our distribution force or distribution weight, where we will see later in the course. Okay, so what it means is that the force now, instead of being applied at a single point in the body, it is being applied continuously. And it will be something that looks like, if this is my beam, then I have a force that is being applied continuously over my body. It looks like a 1D pressure, right? So what it means is that the unit will not be Newton anymore. Instead, it will be Newton over meter. All right, so this is our distribution force or distribution weight, and we will talk more about it later, but just know that there is other way of applying force to a body instead of just applying it at one point. Okay, this is all I really want you to know at this point. And second thing is coplanar force. Okay, so as the name suggests, coplanar force, that means all the force are really acting on the same plane, right? So in this case, it normally means your XY plane. And coplanar force is important in the sense that it hints that all your questions asked will be a 2D problem, right? Because I'm sure that your lecturer have already told you that in your CIV100, you will have 2D and you will have 3D. So when you see coplanar force, means that you are really dealing with the 2D problems. Sometimes your lecturer might be kind enough to tell you that this is a 2D problem, but if they don't, and then they say, oh, these forces are acting coplanarly, that directly implies that this is going to be a 2D problem. Because as you will see later, there are different methodologies, there are different steps that you need to take to solve a 2D or 3D problems. All right. And then the last one that we have to know is collinear force. And what does it mean by collinear force? That means that the force, they are acting on the same plane and same line of action. So which means that it's coplanar plus they are acting on the same line of action. Okay, and these collinear or same line of actions will have some implications on the problem that we want to solve as well, because it tells you that the two forces are on the same line of actions, and then there will be some methodologies or steps that you have to take in order to solve them as well. So I just want you to recognize these terms and know what they imply, and then if that affects whatever methodology that you're supposed to take to solve your problems. All right, so do we have any questions until this point? Right, great, so let me know. And the next one, it's really just significant figures, which I'm sure your lecturer has already covered about it, but I just want to stress it again to make sure that everyone is absolutely clear on this, because this is the last place that you want to lose mark, right? Because it takes 20 to 30 minutes to finish your questions, but because you miss a significant figure, you get 2 out of 10 taken out, and that's the last thing that you want to do. Right, so for intermediate works, always use 5 significant figures, and you don't have to retain your unit. If you like to, it's okay to retain, but you don't have to. All right, you don't have to rewrite your unit every single time, and you just have to be absolutely clear that what will be the unit of your final answer, and then that's fine. But then when you come to final answer, you use 3 significant figures, like for example, 3.59 Newton, or if it's asked your mass, then 4.29 kg, right? So you want to make sure that you know exactly what significant figures are you supposed to be using. But if your final answer involves the first digit is 1, then you need to retain 4 significant figures. For example, we have 1.439 Newton meter, which is the unit for moment. You have 1.354 Newton meter again, and it's not just for 1 point something, right? It's, for example, 12.45. If it's 12, or it's 100, let's say 101.2, okay? And with whatever unit that you need. All this will require 4 significant figures as well. It's not just for 1 point something, okay? If it's 11 point something, 15 point something, 100 point something as well, you need 4 significant figures, okay? Just to be clear on that. And always, always, always make sure that you have units, okay? Check that if you have units. As I said, the last thing you want to do is miss out on your significant figures and units, because that you'll lose a disproportionately big, I would say, big portion of point just for not including your units and your correct significant figure. Okay, and CIV100 professors are really strict about that. Okay, they have their own standards. Like for example, your assignments, you have to use certain type of paper. They do have their own standards, so you make sure to follow that. And so the next thing that we want to talk about is how are you supposed to, sorry, I have a question in the chat. Yes, if it doesn't start with 1, it's like the first example, you do 3. Okay, that is for your final answer only. For any intermediate work, always do 5. Regardless if it's 1 or not 1, intermediate work, always keep 5, because that is your safest options. And then keep 3 for the final answer if it's not 1, and then keep 4 if it's 1. It's basically just standards, all right? And then how are you supposed to go about tackling your problem in generally in CIV100 is that first you want to read your problem carefully, right? You want to see any terms or hint. That is why I asked that you be familiar with coplanar, collinear, and there are other terms that will come across later that kind of imply or give you a hint about the type of question that is being asked, right? So you want to pick up any keywords that's being asked, because sometimes they'll give you a direction on how you should proceed with the questions. And second thing is free body diagram, obviously, but I will go through a practice with all of you on drawing about free body diagram, even though that's probably gonna be your major focus for the next 2 weeks, but we'll go through it together a little bit later. And then the third one, it's really to use the equations or concepts to solve the problem step by step, right? And I'm not sure if you know this, but like for all CIV100 questions, it's more important that you draw the correct free body diagram and write the correct equations rather than getting the right numerical answers. Okay, the prof once told me this: if you have absolutely no idea what to do at all, just draw a free body diagram. You'll get a 3 out of 10, and that's a good investment of your time, right? Draw a free body diagram, get a 3 out of 10, and if you write down the correct equations, you're basically guaranteed a 6 or 7 out of 10, even though you have no correct numerical answer. So always, always, always draw your free body diagram and write down your correct equations to demonstrate to them that you know which concept to use, and that will guarantee you a 7 out of 10 already, even without a numerical answer, all right? And the last thing that I kind of want to talk about is the order of magnitude. So as you go into the course, you will kind of develop a gut sense about what my numerical answer should look like. And it will normally be in the range of, like, I say, a few newtons to 100 newtons to kilonewtons, right? These are okay. These are normal. This you will see 99% of all the time. But if your final answer is something like mega newton or something to the 6 newton, or like something millinewton, then you might want to question your own working and go back to the course, go back to your questions and see that if you have made any conversion mistake or calculation mistakes. Okay, this is this is really something that you should develop throughout the course, because it saves you a lot of time. It's like a quick check, and then it saves you from losing some unnecessary marks, okay? Because CIV100 is really quite hard as it is, and you don't want to lose mark over things that's not necessary. So as I said, kilonewtons, newtons are fine, but like if you come across mega newton or just like millinewton, these things are ridiculously small or ridiculously big. So unless you are dealing with something that's extremely heavy or extremely light, you shouldn't come across these units, okay? And next, I want to go. Okay, so until now, anyone has any questions? Do you have questions? No, you're good. Okay, just let me know. Raise your hands or type in the chat if you have any questions. All right. So the next thing is trigonometry, which I'm sure you are all familiar with. So I don't want to dwell into it too much. I'm sure sine, cosine, tangent, you're all quite familiar with it. And if you are not, then you should really pick up on that. I just want to point out that another very useful equations is really like tangent theta equals to sine theta or cosine theta. Some of you might not know that. I'm sure you'll come across it in your Calc 1. But this is very useful when you have equations with sine and cosine on each side. Right? Because as you can imagine, if I have all sine at one side and then all cosine at another side, then I can just factorize them and then divide sine by cosine to get the tangent theta. So that most of the time will be the only way to solve any equations with sine on one side and cosine on the other side. Okay, it doesn't come out as often, but I just want to make sure that you're aware of that. And it will be useful sometimes when you are writing some equations with a bunch of sine and cosine, okay? And another important thing that I want to point out is that you have to be very careful to treat the axis in which this angle is referring to. Because what I mean is that, for example, if I take the diagram that we have here, for example, if I take the theta, my final theta is really just this, just this theta, right? But because if I have an x and I have a y axis, and I'm asking you what is the angle with respect to the positive x-axis, then there is some addition and subtraction that you have to do to get the correct angle. Am I clear about that? Am I confusing anyone? Is anyone confused about that? Because that is a very common mistake, okay? It might seem like quite a dumb mistake to make, but a lot of people, like when they get the theta, then they just automatically assume that it's the final theta that they're looking for. But a lot of the time, the question will ask you that what is the resultant force with respect to certain axis, which is normally positive x-axis. So depending on the quadrant that you are at, you will have to do some addition or subtraction to get the final answer with respect to positive axis. Am I clear about that? Okay. Let me know if you have any questions, all right? Don't be afraid to ask. I'm really here to cater to your pace and make sure that you really understand what we're going through now. And obviously, like this kind of trigonometry equations, they are only useful for right angle triangles. So you shouldn't assume something is right angle triangle until you're absolutely sure. You can't just look at the figure and be like, hey, this looks like right angle triangle, so let's use these equations. Okay, it will only be a right angle triangle when the questions indicate so. Either they draw a small like rectangle like that at the base of your angle, or either they say that they are perpendicular, or can everyone hear me clearly? Okay, cool. And so the next one that we have is sine rule. So sine rule is a very useful triangular, I would say, law or rule when you have two sides, right? When you have two sides and one opposing angle. So which means that, for example, if I have small b and small c, and then I have either, okay, it's either big C or big B, then I'll be able to find the other one. So for example, if I have small a, small c, and I want to find big C, then I'll be able to do so, okay? So it's very useful if I have two sides and one opposing angle, or the other way around, when I have two angles and one opposing side. Is anyone confused about that? That is very, very important because And it is very powerful because you can use it on any triangle, right? For sine, cosine, and tangent, you can only use it on right angle triangle. But the sine rule, and as we'll see later, the cosine rule is actually applicable on any type of, on any single type of triangle. So I want to make sure that you are really, really clear on that. Sorry. All right. So the next one is cosine rule. So as you can see here, this is your cosine rule. The small ABC indicates is the side length of the triangle, and then the big C is really just the angle between them. All right. So this is useful. When is this useful? When I have two sides length, like for example B and C, and the angle that is being, I would say, the angle between them. All right. So in this case, it's useful because I can find the third length. It allows me to find A in this case. Or for example, I have small c and small a, and the angle between them, which is big B, then it allows me to find small b. Okay, so this can be used to find the side length. Or on the other way around, if I have all the three sides, I have all the three lengths, which means I have A, B, and C, I will be able to find any angle that I want, right? By just repeating to use these equations. Remember, because I have three side lengths, then I should be able to find any angle that I want. In this case, it says C, so in this case, it says small c squared, so I'm supposed to find big C. But I can easily replace these equations with, say, a squared equals to c squared plus b squared minus 2cb cosine big A, right? In that case, I should be able to find big A as well. So as long as I have three sides, I should be able to find any angle within the triangle, even though it's not a right angle triangle. Okay, I hope everyone is clear with that. Is there any confusion? Any questions? Very good. All right. So if there's no questions, I'm just gonna continue until there's questions that pops out, okay? And the next one that we're gonna go through is force vectors, which is really I would say the beginning of CIV100. Whatever we go through before this is more like a review. So as you know, force is vector quantities, right? And so what that means is that it has both magnitude and directions. And the only thing that you can use to represent a magnitude and directions is a vector itself. That's why you call it a force vector, because force itself is a vector quantity. And in order to represent a vector quantity, well, guess what? You need a vector, right? So before we can go into more about force vector, you have to understand the basic operations of vector, because that is how you're going to deal with other force vectors later. So the first one is really multiplications and division by a scalar quantity. They are both the same, right? Multiplications mean I'm multiplying by something that's bigger. I'm multiplying by something that's bigger than 1. And then division, what it really means is that I'm dividing by something that's, I'm multiplying by something that's smaller than 1, right? That's all it is. And obviously, as you can see on my example here, if I'm multiplying by something bigger than 1, then what it does is that it's just increase the magnitude by the amount of scalar. And by magnitude here, it means the length of the vector itself, right? So if I have 2a, then the length is double. And if I have 3a, the length is triple, right? That's easy. And then if I have, say, 0.5a, then the length is half of the original length. Are we clear on that? And what if I'm being multiplied by a negative quantity? For example, if I'm being multiplied by -1, what it does is that it will scale your magnitude of the vector proportionately, and at the same time, it will flip your vector, right? Your direction is reversed. So in this case, say I have A, and then when I've multiplied by -a or -1, then my direction is just flipped. And if being multiplied by a -half, that means my magnitude is decreased by half, and then my direction is also flipped. Okay, I think that's pretty straightforward for you guys. And Now, the good stuff or the more important stuff is that vector addition. And why vector addition is important? Because it is the underlying process of finding your resultant force. I'm sure like until now, you all have been seeing a lot of find the resultant force, or the resultant force is acting this way. What are the components? So how am I supposed to do that? It's really through vector addition, right? Because it is the basic process of finding your resultant force. And there are actually more than one way to do it. There you can do force resolutions, which is, I would say, math, right? It's a mathematical, it's systematic mathematical approach to do vector additions and to resolve your force. Or you can do parallelogram law or triangle law. They're both the same, which is, I would say, involves drawing, right? And when you do parallelogram law or triangle law, which we'll go through later, you have to make sure that your drawing is always up to scale. And you have to make sure that your drawing is, you have to make sure that you draw everything exactly as it is, right? According to your scale, including the angle itself. So obviously, when you do a vector addition, you have to take care of the magnitude and the direction, because that is the whole point of us dealing with vector in the first place. Because force, we have to care about the magnitude and the directions. So obviously, when you're doing the operations of it, you have to preserve both information until the end to get the accurate answer. So as I told you, that vector addition is the process of finding the resultant force. What do you mean by finding the resultant force? That means really like adding forces together, right? It really means like adding, it really means adding forces together. So conversely, if you use the same analogy approach, you know that force can also be resolved into its principal components, right? So what it means is that if I give you a force, I should be able to tell you what are the components that make out of it. Okay, and most of the time we resolve that into its principal components, right? In questions, when you see principal components, it really just means your X, Y, and Z axis. And I have to stress here that there are infinite amount of ways that you can resolve your force into. You don't have to resolve it into X, Y, and Z axis only, right? You can resolve it into any axis that you want, even though they are not perpendicular. But the only reason that we resolve that into X, Y, and Z axis is because they are perpendicular. So we can use our sine, cosine, and tangent to deal with them. So it's really just for the ease of calculations, and it's easier for our mind to process. Okay, you don't have to, but you do it just because of the ease of calculations. There's no rule or law that says this is the only axis that you can resolve your force into. But you do it because you have the mathematical equations for you to deal with it. Okay, that's all it is. Do you have any questions here? All right, great. So now let's go into force resolutions. So what it means by force resolution is really means by breaking down my resultant force. Sorry. Right, it means that I'm breaking my force into its principal components, which means in 2D, there will be X and Y axis, and then in 3D, there will be X, Y, and Z axis. We're gonna start with 2D because that is the, I would say that's the foundations, and then once we are familiar with it, then we'll go into 3D. All right, so given the force F, as you can see in the picture here, given a force F, and then an angle theta between the force and the X axis, then because cosine theta is just Fx over F, right? So naturally Fx is just F cosine theta. And in that case, my Fy is just F sine theta. And be clear that in this case, my theta is given between the F and Fx, right? So if my F is given between F and Fy, well, then the equation will be flipped. In that case, my Fx will be F sine theta and my Fy will be F cosine theta. Okay, so you shouldn't memorize that Fx is always F cosine theta, Fy is always F sine theta. It's not always true because that can change depending on where your angle is given, right? Obviously, because this is 90 degrees, so if I'm given the angle between F and Fy, I can always find the angle between F and Fx. But you shouldn't just memorize that, right? All these comes from the sine, cosine, and tangent equations that we dealt with just now, okay? It's just a natural rearrangement of your sine, cosine, and tangent. But most of the time, I can tell you 90% of the time in your exam, your prof won't give you any of the angle, right? You won't see any 30 degree, 60 degree, or 45 degree in your questions. If yes, good for you. Just make sure that you are using the correct sine and cosine for your fx and fy, then you're good. But most of the time, what your prof will give you is something triangle that looks like this, right? Like it can be 3, 4, or 5, or it can be anything. It can be like, say, there's one is what? I think there's one is 12, 13, and 15. Sorry, 15, right? And all these are called triangle pair. Triangle pair means that all these are right angle triangle that there are a pair of number that fulfills the Pythagoras theorem, right? Pythagoras theorem tells you that the hypotenuse square is both sides square and added together, right? So like 5 square, which is 25, is 3 square plus 4 square. And there are a lot more pairs other than that, but the more common one is like 3, 4, and 5, and 12, 13, and 15. So in that case, because I don't really have any angle to deal with, obviously you can find the angle by taking inverse sine or inverse cosine, but that is actually a trouble itself, right? So if I have this angle, what I really want to do is that I just take, okay, let me show here. So for example, if this angle is, this triangle that given is 3, 4, and 5, and if I want fx, it's really just f times the length of whatever that side that you want on divided by the hypotenuse. Are we clear on that? So for example, in this 3, 4, 5 triangle, because if I want fx, it's really just f times 3 over 5. And if I want fy, it's really just f times 4 over 5. You just take whatever side that you want, depending on if you are finding fx or fy, and then divided by the hypotenuse. This is how your prof is going to give you the angle information in your exam. Your prof is not likely going to give you the data, but they'll give you, like for example, if they draw the force here, and then they'll just draw a small triangle down here and give you 3, 4, right? And then if you get 3, 4, naturally you should know this is 5. If you don't know, then you can calculate it with Pythagoras theorem. And then in that case, if this is my x-axis, if this is my y-axis, then fx is really just f times 3 over 5. And fy is f times 4 over 5. Are we clear on that? Right? So this is how your angle information is going to be given in your quiz, in your midterm. All right? Cool. And once you resolve your force into fx and fy, then you can just add them component by component. That is the whole point of doing force resolution, right? I want to resolve them into fx and fy. And if I have more than one force, then I can just add everything together in fx and then add everything together in fy. And then I will later use some equations to add them back together so I can know what is my final resultant force. All right, are we clear on that? Is there any questions or doubt? Anything that you want me to pause right now and explain further? Are we cool? All right, cool. So just now I'm teaching you about force resolution, which means that I'm given a force that is not lying along the axis, then I know how I'm supposed to resolve that into fx and fy. Now let's say I already add and subtract all the force in my components, and how am I supposed to combine these forces back so that they become a single resultant force with magnitude and directions, right? Remember, force is a vector, so in my final answer I need to have a magnitude and directions. So to find the magnitude of my force, I can use the Pythagoras equations, in which that says that magnitude of f is really just the square root of fx squared plus fy squared, right? This is directly the result of Pythagoras theorem. And to find the theta, it really is just the inverse tangent of fy divided by fx. Again, I have to remind you that you have to be careful what quadrant your force is, right? Because there's 1, 2, 3, 4 quadrants. And depending on which quadrant your force is, the theta that you find here is different. And you might have to do some additional manipulations to get the angle of the force with respect to your positive x-axis, right? 99% of the time, your prof will ask you what is the force direction with respect to the positive x-axis, okay? So the theta might not be the direct answer. If your force is in the first quadrant, well, yeah, then congratulations, your theta is really just the theta with respect to your positive x-axis. But if it's say in the second quadrant, then this is your theta, right? This like the theta that the equation gives you is really just this. And to get the force direction with respect to positive x-axis, I have to take 180 degrees, subtract the answer, okay? So I hope that is clear. I know I'm repeating myself, but this is very important to make sure that everyone has a good understanding of that. All right? Are we good? Okay. And next one is triangle law, which I'm not gonna go too much into it because to be honest with you, like I only learned that during the first chapter of my CIV100 and I never use it afterwards. Because there's no way that your prof will ask you to draw, to do like force additions using triangle law or parallelogram law in the midterm, because there's just too much variation, right? Everyone can have a different skill, and everyone can have a different, I would say there will be a varieties of angles that are being measured, right? Because everyone is using their own judgment in measuring the angle, even though you are using a protractor, and everyone can have a different skill. So it's too difficult for them to mark it on a systematic marking scheme. So I'm not saying it's impossible, but it's not likely to come out. Our prof said we should never use the triangle law. Well, I mean, the triangle law is really just the parallelogram law, right? If I add these two sides together, that is the parallelogram law, right? The difference between parallelogram law and triangle law is that in triangle law, I can do, yes, it is not possible in the physics aspect. It is merely a tool for you to find your, it is merely a tool for you to find the resultant force, right? So a parallelogram law, it's like an extension of triangle law, but the disadvantage of parallelogram law is that it only allows you to add two forces together, right? But if triangle law, I can like add infinite amount of force together as long as I connect them head to tail. But anyway, you don't have to worry too much. If your assignment asks you to use parallelogram, please do so. All I'm saying is that you don't have to worry too much if you are not an expert in this, because I don't see a big portion of your midterm to have anything to do with this, because there's just too much uncertainty in terms of marking and controlling the quality of your answer, right? So you really have to make sure that you know force resolution, because that is a mathematical systematic way that everyone will get the right answer no matter what you draw, right? The only thing that I want to remind you, if you use parallelogram law, is that you have to make sure that they are up to scale, right? So once you set a scale, say like 2 Newton is proportionate to 1 centimeter, then you should keep that throughout. And then you have to make sure your angle measurement is always accurate. All right, that's all I'm gonna say. I don't want to waste too much time on this. And yes, if your prof said so, then you should listen to your prof. It's just don't worry too much about it, because, well, let's just say it's not worth investing a significant amount of effort in it, right? Cool. So that is our 2D force resolution, which I think is relatively straightforward. And we're gonna go through one. Actually, I prepared 2 questions, but I think I'm just gonna go through one of them with you because I think it's relatively easy. And then I want to spend a little bit more time in the 3D force resolutions and your Cartesian vector. Is that okay for everyone? Right, good. So the first questions. Okay, so I'm just gonna read out the questions. So the guy wire BD, okay, this is B, this is D, exerts on the telephone pole AC, this is C by the way, a force P directed along BD. And knowing that P must have a 120 Newton component perpendicular to pole AC, determine the magnitude of the force P and the component line along AC. Okay, so if I were to draw a free body diagram, sorry, I don't have a ruler with me, but for any free body diagram, you should always use a ruler. Okay, I don't have a ruler, so it's gonna look a bit crooked. So if this is A, this is C, and a free body diagram of the string is really just a force in these directions, right? Let's call it tension T. Remember, string can only exert tension which means that the force will always have to act away from the object that you are drawing, okay? Because string can only be pulled, it cannot be pushed. So no matter what object I'm drawing, the string, the tension will always have to be going away, right? I mean, because when I tell you the string currently exert tension, some people might have difficulty understanding it. I think one very good way to remember is that any force related to string or wire, the force will always be directed away from the object. Okay, it shouldn't go towards the object. As easy as that. And the question is telling me that this is 120. Oh my God, sorry, my touch screen is not super helpful. So it's saying that this is 120 Newton, and then it's saying that it's giving me the angle as 38 degree, right? And then it asks me what is the magnitude of the force. So if I do a force resolutions, this is my Fx, this is my Fy, and it's telling me that this force is, it's telling me that this force is 120 Newton. Wait, give me 1 sec. Let me go back to my notepad. Okay, so all it's telling me is that there's 120 Newton on the Fx direction, right? And I'm being asked, what is the force T? Knowing that this angle is 38 degree, right? So that is really all the question is asking. So again, because this is a right angle triangle, and why do I know this is a right angle triangle? Because it says that P must have a component perpendicular to pole AC. So knowing that, I automatically resolve my force to Fx, which is perpendicular to pole AC, and then there's Fy that is parallel to pole AC. And because they are perpendicular and parallel, obviously the whole angle has to be 90 degree, right? So in that case, I can definitely use my force resolutions. So in that case, if I use sine, then I know that sine 38, it's really just 120 divided by T, right? So if I rearrange, T is 120 divided by sine 38, and that will give me 194.9 Newton, right? See, 4 significant figures that goes along with the with unit, right? So now I know that T is 194.9 Newton. The next questions ask me what is the component along line AC. Well, I mean, that is, again, I just use, now that knowing T, then I can say that cosine 38 degree is really just Fy divided by 194.9. So Fy, after rearrangement, it's really just 153.6 Newton acting downwards, right? And then T is acting in that direction, 38 degree. This is given by the questions. This is really a basic demonstration of the force resolution that you should be following. And anyone has any questions on that? I think that is pretty simple. Do we have any questions? Okay, great. The second questions, I want to spend a little bit more time in the 3D, so I'm gonna skip it, but I will release the solution later on, so that in case you decide to practice. All right, so a hint that I'll give you is that be careful of the in idle cable, right? That is what I mean by reading the questions very carefully. If you give you directions on where you should start the problem and how you should approach it. It says it will not exceed 60 Newton in idle cable, right? So if you think about that, then it should give you directions on how you should proceed with your questions. Okay. Okay. Do we have any questions before we go into 3D Cartesian vectors?
Excuse me.
Sorry?
Can you hear me?
Yeah, I can.
So far you've kind of been going over like questions with uh when they're directly the x and y components are directly placed on the uh x and y axis, but what if when they're not? They're kind of like angled away from the x and y.
Okay, let's go back to that question. Are you saying that, but my force in this case is not in the x and y axis, right? I'm just resolving them into the x and y axis purposely. Can you repeat your questions? So I mean,
Um,
yeah.
because over here it's kind of like a right angle triangle, right? And
Uh,
so you could use the sine cos, and but what if when it's not? When
it will
if
always.
you have a question.
Okay. So in that case, that's when you use your sine rule and cosine rule, because that can be used for any triangle, right?
Okay, and so you have to have a certain amount of sides known or angles known and stuff.
Yeah, but 99% of the time I will be using sine and cosine because I'm the one that choosing to resolve the force into x and y axis, right?
Okay.
Because like this force itself obviously is not directed along an x and y axis, correct? But okay, I get what you mean. So like say if today I have a ram and then I have a force here. I have a force that is directed along the ram, right? Let's say I'm pulling something up the ram, and
Mm-hmm.
then there's a force, and then maybe there's a weight, right? This is your weight, and then this is your tension. So in that case, yeah, I might not resolve the force directly along x and y axis, but what you do in this ram kind of situation, you always resolve your force parallel to the ram and perpendicular to the ram. In that case, it's still perpendicular, right? It is not like exactly horizontal and vertical, but you always choose to resolve the force in a perpendicular pair of manner. And the reason I do that, as I said before, is just so I can use my sine, cosine, and
And then
tangent.
cos. Okay.
Yeah. So,
Okay.
yeah, I mean, there will rarely be a case where you cannot resolve your force into perpendicular angle because you are the one that choose to do that, right? You are
So
controlling it, and that shouldn't be changed by any type of the questions that's being provided.
so even if for example if we're given a question but it doesn't have enough sides or enough angles known for us to use the sine or cosine law, we should always try and resolve it into like components
Yes, you
and
should
then
always
solve it.
yes, you should always try to resolve it into perpendicular components, right?
Okay.
Because as I say in the beginning, you don't always have to resolve your force into perpendicular components. I can say like if I can always choose to resolve my force into say this component, say component A, and this component B, and obviously they are not in a right angle triangle, right? But why am I gonna do that? Why do I want to make my life such a pain by not doing that, right? The only reason I want to resolve that into perpendicular component is just so that I can use sine and cosine. It really is as straightforward as that, right? Because obviously this is not a right angle triangle. So if I have a force, say here, and I ask you to resolve the force into component A and B, then I have no choice but to use a sine rule and cosine rule, right?
Okay, and then you can't. Oh, okay.
Because in this case, if I do my parallelogram law, then it says that this is A, this is A, and say plus B has to be equals to T, right? Okay,
Mm-hmm.
sorry, this is a bad triangle, but you see what I mean? So if this is A, this is B, this has to be equals to T, right?
That's triangle, yeah.
So, but in that case, because A and B are not perpendicular to each other, I cannot use my sine and cosine. And I have to use my sine rule and cosine rule. I
Okay,
cannot use the right angle sine and cosine.
because you can't break it up.
Yeah, yeah.
Okay.
All right. I hope that's clear for you.
Yeah.
Okay. I have a question in the chat. See, can you share your slides after? Do you all not have this package? I thought we sent it out to you before. Do you all have this package? Whatever I'm sharing right now? Can someone answer me? No?
No, I
Oh,
don't think so.
yeah. Some have, some don't. Can we confirm? Is like, do you all have have this package with you? Can somebody tell me?
Oh wait, yeah, it was sent with the email for the Zoom link.
Yeah, I think it was in the email. It was supposed to for you to follow along, because obviously I can't send you a paper copy. So if you have an iPad with you, it's meant for you to follow along and write down things as you go. And if you don't have an iPad where you can write, then you'll have to write on paper as you follow along. I'm sorry about that. Will we go over unit vector in the future? Yes, that's coming up. And I think that's the thing that confused most people, the 3D unit vectors. So that's coming up. Yeah, that's important. Okay, are we good to proceed? Any more questions? Since I'm already answering questions, are there any more questions? If no, then the next thing that's coming out is Cartesian vectors in 3D, and that includes unit vector. All right, cool. Sorry, my handwriting is a bit poor today because my touchscreen is not working as I expected it to be. It's a bit sensitive, so I'll try to talk more and try to write less. So you should write down what I want to say. All right, cool. Okay.